Okay, good evening, everybody. So, in the last class, we discussed about different data types. So, why do we need a data type? As we look into this table has three columns, that is employee ID, employee name, and salary. Now, these three columns, we have to make sure that the data entered into a table must be validated. There should be a simple basic intelligence from the tables in, so that we would be able to validate or make sure the right data is entering inside the right column of the table. So for that we were using something by name data type. So data type in SQL, we have character data type, varchar data type, varchar2 data type, number data type, date, and large object, and everything we saw more in detail in today's class. In order to make sure that data entered into a table should be validated, the second way of validating a data that is entering into a table is by using constraints. So let us deep dive and understand what are these constraints, why is it used, and what are the purposes of these constraints. But as of now, we, in order to validate the data, making sure that the data entering into a table should be validated. That can be first validated using data type. That one we have already seen. And we are seeing a new concept. In order to validate the data that is entering into a table, we have the second important concept that is called as constraints. So let us understand what is a constraint. Okay. So what are constraints? So what are constraints? The word itself is saying that constraints is nothing but there are certain rules and regulations and certain principles or guardrails that we are giving. So that is what the definition that the word constraint itself tells us. So let us understand, a constraint in SQL is nothing but a rule applied to a column or a table, okay, that makes sure that the validity or that data accuracy is correct and the integrity of data is holding good. For that reason, we are using constraint. So let me say a constraint in SQL. A constraint in SQL is a rule applied to a column, is a rule applied to a column or a table, okay, that ensures, if we understood that constraints is nothing but a rule or it is a law that we are applying to a column in a table, or we are applying to the entire table. Why we are applying? To make sure that that ensures the validity, meaning the data is holding good, that ensures validity, accuracy, okay, that ensures validity, accuracy, and integrity of data. Now, this might be little going above your head, but slowly you will be able to understand this one. A constraint in SQL is nothing but a rule applied to a column or a table that ensures the validity, accuracy, and then integrity of data. So let me take up this Facebook sign up form, Facebook sign up page, and explain something important here. So we all know that this is a Facebook sign up page. Okay. Okay. Let me come here. Just a minute. We all have this Facebook sign up page. So in this Facebook sign up page, we have the first name, the surname, the mobile number or email address, and then the mobile number or email address and the new password we have to give. Now, in this first name, whatever the text box that you're seeing in this application, Facebook sign up page, every text box is acting like a column in a table. Understand like that. The first name should be and accepting only alphabets. It is not good that somebody's name cannot be 1 2 4 3 4 5 6. Everybody's name should be in alphabets only. So this first name should only accept the alphabets. That is a constraint that I'm applying on my particular first name column in the Facebook table. And the surname should always be a characters only. It cannot be any numerical data. So first name and surname, I'm applying a constraint. The constraint says that the first name and surname should be alphabetical names only. It cannot have numerical names in it. Okay. And the next thing is that here in the birthday thing, I have a drop down where I have day, month, and year. In this day, month, and year, it is expecting only numerical data. I cannot go and give alphabetical data there. So the birthday column in a table, in Facebook table, the date, month, and year is expecting a numerical data. So there is a numerical expecting constraint they are applying. So coming back to this concept, a constraint is a SQL. In SQL is a rule applied to a column or a table that ensures that validity and accuracy and integrity of data. Now let us understand why this constraint is needed. Why constraint is needed? If at all constraint is not there, in first name, instead of entering alphabets, people might use, they might enter numbers, and nobody's name can be in numerical names. It is all, names should be meaningful, and henceforth, numerical data should not be passed inside the first name and surname. Okay, so why this constraint is needed? Let's understand. Without constraints, database would accept anything and everything. Okay, so let us understand. Without constraints, the database would accept anything and everything. It is not good to accept database accepting anything and everything. It should accept only meaningful information. It should accept only meaningful data. In this case, without constraints, if we are working, there would be so many duplicate values. There is already a person by name Karthik. There cannot be another person by name Karthik in the same account. In Facebook, their two names cannot be same. There should be some uniqueness provided to the account. So duplicates, if we don't have constraints, duplicates will be allowed. And then there are possibilities that we can leave blank spaces and also try to create an account. So null values can also be included, and then some invalid data can also be included. Invalid values can also be there. In order to avoid all these things only, we are going with constraints. So constraints, without constraints, database would accept anything and everything. It might accept duplicates, nulls, invalid values, but constraint makes sure that only meaningful and consistent data enters into the table. Okay, constraints make sure only meaningful and consistent data enters into the table. Okay, so we understood what are constraints, we understood why constraints. Now let us understand what are the different kinds of constraints that we have in SQL Server. Okay, types of constraints. Is everybody able to understand types of constraints in SQL Server? Types of constraints in a SQL Server. What are the types of constraints we have? The first thing constraint, we have something by name not null. Not null constraint. What is this not null constraints? Say suppose I am creating a Facebook account. I am creating a Facebook account. Here when I am trying to create a Facebook account, in first name, I cannot leave the name blank. I cannot leave the last name blank and then give just the email address and password and sign up. First name is mandatory field and last name is mandatory field and email address was also is mandatory. So there are chances that if I want to emphasize that there are certain columns that we cannot leave that empty. For that reason, we will be using something called as not null constraint. What is this not null constraint? This not null constraint is telling me that ensures a column cannot store null or empty values. Okay, ensures a column cannot store null or empty values. I will bold this one. Bold is ensures a column cannot store null or empty values. What does it mean? By default, you want to have the first name and last name, you want mandatorily you wanted the first name, last name to be filled in. In that case, you will use this not null constraint. Ensures a column cannot store null, empty, or blank values. Okay. So it says that uses when the field is mandatory. Uses when the field is mandatory. Whenever the field is mandatory, you can use this not null constraint. Say, for example, let's take up an example of a student table. In student table, the student ID and the name of the student cannot be null at all. We should definitely have the student ID, and also the name of the student in the student table is mandatory. So that cannot be null. Okay. Student ID and the name cannot be null. So that is mandatorily be needed. So in that case, student ID and name in the students table cannot be null. And in that case, sometimes, there are chances that, we don't want to mention our age in couple of online forms. We try to skip that one. So age can be null. Age can be null, but student ID and name in a student table cannot be null. But age in any online form, you don't want to declare your age. In that case, age can be null. We can leave blank space. So not null, did you understand? Not null tells us that you cannot leave a blank space, or you cannot leave an empty values or null values. To emphasize that one, we uses not null constraint. Deepak and others. The next constraint what we are going to learn is called as a unique constraint. What is this unique constraint? This unique constraint is also something very interesting. Say we all have email address. So if my email address is karthikjohnbabu@gmail.com. So I that is unique to my name, and it is a unique email address. Nobody else can have the same email address. Likewise, this unique is a constraint which makes sure that all the values inside that column are unique and there are no duplicates inside that one. So ensures all values in a column are unique. Say, for example, if at all in the Aadhaar, we should be having mobile number to be unique. So every person will have a unique mobile number. So there is a unique constraint applied on the Aadhaar table for a mobile column. So there no duplicates are allowed. Every person will have a unique mobile number. Okay. So what is the thing that you can what are the things that you can talk about here? It says that use when the field is allows ensures all values in a column are unique and no duplicates are allowed. And here in this unique constraint, there are so many, say for example, let me take up an Excel sheet and I will explain this one. Okay, I'm taking up an Excel sheet. In this Excel sheet, there is a student name, and there is another column by name student ID. Okay. Now listen carefully. The student, we are having five students. So we are having 1, 2, 3, 4, and 5. And the student name is, say, for example, Kiran. And the second student name is Pavan. And the third student name is Suresh. And the fourth student name is, Rekha. And the fifth student name can be blank. That is what I'm trying to say here. What does it mean here? This student ID is having unique values. The student name is also having unique values, provided there is no null value repeated second time. Okay, there is only one null value inside the student name, so that the student name can accept only one null value, and that one null value can be unique. Okay, that is the point that I want to emphasize here. So coming back here, it allows null value once in a SQL server. But that null value is not unique. But in SQL Server, that null value for temporarily it can be allowed once. You cannot have another null value. So you cannot say that two null values are unique. No, only once That null value can be allowed inside that table, provided that student name is having a unique constraint, and in that unique constraint applied, you can have only one cell or one particular value that can be null. Okay. And the next thing is that no two employees can have the same employee ID or email. So in that case, we want to make sure that no two employees having the same email ID or same employee ID or email. We will be applying on that particular email column, and employee ID, we will be applying this unique constraint. The third constraint what we will be learning is called as the check constraint. Check constraint. What is this check constraint? This check constraint is like a custom condition to validate any values. So let us say that adds a custom condition to validate values. Now you might ask what custom condition that I can apply to any column. Hold on, I will explain. If the condition, if the custom condition is true, okay, if the custom condition is true, then the value is accepted. Okay, then value is accepted. Otherwise, what happens? Otherwise, if you're trying to enter the data into the column, it will get rejected. Okay. Now I'll give you one custom condition example. Say for instance, the percentage must be in between. You're trying to calculate the some percentage in a table. So usually percentage should be represented between 0 to 100. So if at all you are trying to get percentage something above 100, this check condition will never allow to enter that value inside that particular table. So percentage must be between 0 to 100 only. Okay, that is what check condition I have applied on a particular column. Or if at all there is an employee table, in that employee table there is an employee phone number session or a mobile number column. That mobile number should be exactly be 10 digits. It cannot have more than 10 digits. So I am applying a check condition there. So the check constraint will check on that mobile number column that only 10 digits should be present. If it is 10 digit, it will allow to enter that value inside that column. If it is above 10 digit, it will reject. So phone must be exactly 10 digit. Phone must be exactly 10 digits. So this is a check constraint. In short, I will be showing some diagrams. Then you will be able to get more clear picture, and that you will be able to understand more. Okay. The fourth constraint what we are going to discuss today is the hero of the session, that is called as a primary key, or in short we call that as a PK. Okay, the fourth constraint what we are learning now is a very very important thing, and this topic is very very important, and this primary key constraint we will be doing a deep dive, and this primary key in short we will be calling that as a PK. Now let us understand what is a primary key. Primary key is nothing but again it is a constraint or a rule that is applied to a column in a table. Okay, what is it doing? It helps in that primary key helps me to uniquely identify each record in a table. Okay, slow down. First I'll give you some 1 or 2 lines of explanation, and then slowly I will be giving you complete examples, diagrams, and you'll be able to understand. Plus, please listen. A column, what is a primary key? A column, or it could be a set of columns. Okay, a column or a set of column that uniquely, the word uniquely is very important because that is the key word. That uniquely identifies each record, each record in the table, each record in the table. Okay, we understood that primary key is also a constraint that has been applied on a column that uniquely identifies each record in the table. But I need to know how that we can identify uniquely that record in a table. There should be some way to uniquely identify each record in a table, right? For that one, I'll give you one rule: only one primary key. Okay. There is something called as in this primary key. In a table, you can have only one primary key per table. So this also I'll give. Even if you are not able to understand, please hold on. When you see the diagram, you will be able to understand all these things. So the rule says that in a table, you can have only one primary key. Only one primary key per table. I can give you this. Only one primary key per table. And this primary key in short form, we call it as PK. And what are the things that it is composed of? This primary key is basically composed of a unique constraint plus a not null constraint. You already know what is unique constraint. Okay. You already know what is unique constraint. Unique constraint is nothing but, only unique values are allowed. There is no duplicate values. Not null constraint says that you cannot have a blank space or an empty space in particular, in a particular table. So this primary key is nothing but a combination of unique constraint plus not null constraint. That in full form, both these constraints together, we call that as a primary key. Okay. So far, I have not told you what is primary key doing all those things and all. I've only defined a primary key is can be applied. It is a constraint that can be applied on a column, and that column can be is helping us to uniquely identify each records in that particular column or in that particular table. And I have also told you that in a table you can only have only one primary key, and the primary key is a combination of unique constraint plus a not null constraints. Okay, these are the things I have covered. Let us discuss characteristics of a primary key. Then you will be able to, once you are learning all these things, then looking into the diagram, you will be able to understand it completely. Okay. The first characteristics of a primary key is that I want to repeat it since it is already there, but I will repeat it once again. We can have only one primary key in a table. Okay. We can have only one primary key in a table. Okay, understand this point. And then primary key cannot accept duplicate or repeated values. I'm breaking it down so that you understand more in detail. Primary key cannot accept duplicate or repeated values. This is the second most important point. And we this unique only I am writing it as primary key cannot accept duplicate or repeated values, and not null I'm writing it as primary key cannot accept null values. Primary key cannot accept null values. The next important thing, primary key is nothing but, it is a combination of unique plus not null constraint. I am writing that one also here. Primary key is always a combination of what? It is always a combination of unique plus not null constraint. So can I say it is always a combination of unique and not null constraint. Not null constraint. The last thing is that primary key is not mandatory. Remember, in a table, primary key is not mandatory but highly recommended. Okay. Once you look at the diagram, you will be able to understand more in detail. But as of now, grasp all the points what I am giving. Primary key is not mandatory, but highly recommended. This is one classical example. Now, in a table, just imagine a student table. In student table, if you imagine, there should be student ID, there should be student name, there should be some marks. So, in these three columns, which is the most important column, definitely we should know that the student ID is the most important column. So, in a table, whichever you feel is the most important column, that column will not have any duplicate values or null values. That particular column will be treated as a primary key column. Okay. So student ID uniquely identifies each student, and the student ID in the table, the student ID in the student table, likely the student ID will be the most important column. So that will be the primary column or primary key for that particular table. Okay. So far, did you understand these concepts at least a little bit or completely? Yes, no?
Yes, yes, understood.
Thank you very much. Okay, now I'm going to explain another concept by name foreign key. Then I will be showing the diagram because primary key and foreign key are interconnected. Okay, then it makes complete sense. So let us understand what is the foreign key also, and then I will show you the diagram which how it is interconnected and all. So let us understand foreign key. Foreign key, that is in short form we call it as FK. Okay. What is this foreign key doing? The foreign key, the word itself, you will be able to understand that foreign key is trying to, it's like, I can put it in simple words like that, foreign key is, when you are in foreign, you don't belong to that place, but, you are somehow connected to that place. So likewise, this foreign key, it is used to establish a connection between the tables. Okay. And right. It is used to establish a connection between the tables. Used to establish a connection between the tables. Okay, it is somewhere connected, connecting tables. What else it is trying to do? Okay, I am going to give you one important keyword. Try to understand this one. Later, when you see the diagram, you will be able to understand. I am trying to give you the second most important point under the foreign key. This foreign key is nothing but a column that references as a references a primary key in another table. Definitely you'll not be able to understand, but take down this point in your mind. When I show you the diagram, you'll be able to understand. I will come back to this point and I will reiterate why did I say that one. You will be able to understand. A column that references a primary key in another table. Okay, this is the second point. Just hold on to it. You will be able to get this complete thing. Used to link and this linking tables we call it as parent child relationship. And the last point, I want to give you, and then I'll show you the diagram, enforces referential integrity. What is this referential integrity? Very simple. This referential integrity is nothing but, it is trying to connect tables from one table to another table. And, this referential integrity means that you cannot insert a value in foreign column unless it exists in a parent column. Okay, cannot insert a value in a foreign column unless it exists in a parent pk primary key. Okay, so far, you wouldn't have understood anything about the foreign key, but let me show you the diagram and then you will be able to understand. Okay, before showing you the diagram of primary key and the foreign key, let me show you a diagram of what is not null constraint, what is unique constraint, and what is check constraint with an example. Then you will be able to, and then I will show you another diagram for primary key and foreign key. Now I will show you a diagram for not null, unique, and check constraint. Come here. Okay, tool. Okay, you have a diagram here. This diagram, let me walk you through this diagram, then you'll be able to understand. Okay, now whatever you are seeing on the screen is an employee table. Okay, whatever you are seeing on the screen is an employee table. This employee table has four columns or five columns. This particular blue line, what you're seeing, blue color thing, is the column. So you have this employee table is having a column by name employee ID. Another thing, you have a column by name employee name itself. There is a column name, and then employee salary is another column, and date of joining is another column, and phone number is another column. So employee table you are having, and the table is having five columns. First column name is employee ID, second column name is name, and the third column name is salary, and the fourth column name is date of joining, and the fifth column name is the phone number. Okay, so these are the columns in an employee table. Now carefully listen, this employee ID column, we have applied a constraint here called as not null constraint and unique constraint we have applied. What is that? Employee ID column is applied a constraint. It is applied with not null constraint, which makes sure that an employee ID, whenever a user is trying to enter the employee details, the user cannot leave the employee ID empty. He cannot leave the employee ID blank. It will enforce the user to enter the employee ID. Only then the record or the data will be saved, and it will push the user, recommend the user, insist the user to enter the employee ID. That is why this not null constraint is in picture. Next, in this employee ID, we have the unique constraint also applied. Two constraints are applied, not null and unique. Unique constraints make sure that in the entire employee ID, the number should not be holding duplicate values. Every single record, every single data, every single tuple value should have unique values under the employee ID. That is why unique constraint is applied. Okay, and then inside this employee name column, we have applied not null constraint, meaning the name cannot be blank or null. Definitely the employee details, whoever the user is entering, they should enter the employee name. Likewise, they have also applied something, two constraints here on the salary column, not null constraint. Not null meaning saying that a salary of an employee cannot be null at all. There should be some numerical values entered into it, and make sure that the salary should be greater than zero. Could you see the check constraint applied? The check salary greater than zero it is applying. So nobody's salary can be lesser than zero or equal to zero. Everybody's salary should be greater than zero. That is why the check constraint is applied. Date of joining, again, it is not a null, meaning that definitely the employee date of joining data should be entered. And then in the phone number, we have three constraints applied. One is check the length of the phone number equal to 10. So every phone number, mobile number of the employee should be equivalent to 10. That constraint it is checking. Not null. You cannot have an employee phone number or mobile number to be empty or blank. And also we are trying to check whether the phone number or employee is unique. You cannot have duplicate values. Okay, so these are the constraints that I'm applying on a table, and provided I'm validating the right data that is getting entered into a table. Now make sure that the employee ID is a number data type. Could you see employee ID what a data type? Is a number data type, and in name is varchar data type, variable character. Salary is again number data type, which is taking 6 digits it is taking, and after the 2 digit you are placing the 2 digits, you are placing the decimal value. 6 digits meaning the highest digit you can take it is 999 for 6 times, and after from left to right, when you are counting 2 digits, you have to place the decimal or float value. Likewise, the date and numbering for 10 numbers we have seen. Are you able to looking into this diagram? Are you able to understand what is null, not null constraint, unique constraints, and check constraints, and all these things? Primary key and foreign key have not explained, but others have you understood?
Yes, great.
Thank you. Okay, so let me put the diagram here. I'll put the diagram. Now I will explain what is a primary key and a foreign key. Then I will give you some characteristics of foreign key also. Okay, so let me take up a diagram of primary key and foreign key and what it is, so that you will be able to understand and appreciate what it is. Then looking into the definition, whatever we have learned, you will be able to understand more in detail. Now, I have told you RDBMS in the definition itself. I have given you in RDBMS. RDBMS, if we can go back to the definition here quickly, I have given you one thing. What is a database? DBMS, RDBMS. In RDBMS, is a software, is a collection of program that allows user to create the data, maintain the data, share the data, and what is the last thing? Relate the data. So that RDBMS is helping us to do. So looking into this diagram, let's understand what it is trying to say. Here in this example, there are three tables. We are having employee table, we are having customer table, we are having department table. Okay, let me repeat. In this scenario, in this example, we are having employee table, we are having customer table, we are having department table. Okay, this employee table, we are inside this employee table, we are having columns like employee ID, employee name, and salary. We are having these are the three columns of the employee table. Also, we have a CID called as customer ID column also there, and the department number column is also there. Carefully listen, this employee ID, employee name, and salary, these three columns belongs to which table? Employee table. But this customer ID column is from the customer table, but it is present in employee table. Are you able to understand? This customer ID column is from the customer table, but it is also present in the employee table. This D number, department number, is actually belonging to the department table here, but it is present in the employee table. Are you able to understand this part?
Yes, yes, correct.
Yes, okay. Now this CID, this is the customer ID column which is present in the customer table. This CID is actually, it is part of the customer table. But since it is present also in the employee table, I have to tell this is a foreign column or this is a foreign key because it does not belong here. It belongs to customer table. In order to bring a column from another table to another new table, we need to call, we are telling that this is a foreign key, meaning this column does not belong here, but it belongs to another table. That's why we call this as a foreign key. Okay, then this department number in the department table is there in the department table, but it is also present in the employee table. And since it is present in the employee table also, this department number is present. That is why we call, this column is a foreign column or a foreign key. Now clearly understand, I'm going to give you one more important thing. Could you see this orange color mark, orange color thing? Yes, orange or yellow, what do you say? Okay, you see an orange color thing?
Yeah.
Yes, that orange color thing is a primary key. Say, for example, in this employee table, which is the most important key, this employee ID is the most important key because this primary key is a combination of two constraints, that is not null constraint and unique constraint. Definitely there will not be any null values and definitely they cannot be duplicate values. So employee ID is acting like an primary key for this employee table. I told you in the employee table or in a table you can have only one primary key. Could you see that? There is one primary key for the entire employee table. That one primary key is an employee ID column. Now come back to the customer table. In customer table, the customer ID is the most important column, and that becomes a unique and that primary key is applied to this CID, and the CID is acting like a primary key to this particular customer table. Likewise, this department number is unique and it is not null, and the department number column is acting like a primary key to the department table. Are you able to understand? So employee ID is a primary key to employee table, CID is a primary key to the customer table, department number is a primary key to the department table. All these that primary key that is present in the customer table is connected to another table using a foreign key. The same primary key column which is moving to another foreign table. In that foreign table, when you are adding the CID column, and that one becomes the foreign key. Unless and until the data, say for example in CID, what are the data there? 1, 2, 3. Yes or no? In CID, what are the data there?
1,
1,
2, 2
2,
and
3.
3.
So unless and until the CID column is updated in the customer table, only when the data is updated, the CID column is updated in the customer table, only then the value will be updated in the employee table, because CID is a primary key to the customer table. Only when the primary key is updated in the respective table, that value will be reflected in the child table of employee. Okay, if at all the department number in the department table is not updated, you cannot update it in the employee table. Here first department number should be updated in the department table, only then that can be updated in the employee table. Did it make sense? Okay, so all these things, only when you look into the diagram you will be able to understand. Now come and read the things, you will be able to understand more in detail. Okay, what is a primary key? A primary key is nothing but a column or a set of column that uniquely identifies each record in a table. Uniquely identifies each record in a table. So employee ID, customer ID, and department number is uniquely identified in each table. Rules: only one primary key per table. Can we have multiple primary keys? No. Every table is having only one primary key in a table. The next thing, primary key is a combination of unique and not null constraint. Everything is unique here and it is not null. Everything is unique here, not null. Everything is unique here and not null. Okay, and characteristics of primary key. We can have only one primary key in a table. Primary key cannot accept duplicate or repeated values. Primary key cannot accept null values. Primary key is also a combination of unique and not null constraint. And primary key is not mandatory but highly recommended. Foreign key. Now, it is used to establish a connection between the tables. Are you able to look into this diagram and make a meaning from the statement? It is used to establish a connection between the tables. And then the foreign key says that a column that represents a primary key in another table. So this is a foreign key that references a primary key in another table. Able to understand? Yes.
Yes.
Used to link two tables. So this is for the customer ID. The customer in the customer table, the customer ID, the CID is a parent table, and then the CID, the column which is also present here in the employee table, this one will be acting like a child. So used to link tables, parent and child relationship. The parent for CID is customer table. The child for CID is employee table, because CID originally belongs to customer table. Department number originally belongs to department table. Wherever it originally belongs, that is the parent, and wherever it is moved to a foreign place, that becomes a child. Enforces referential integrity. What is referential integrity? Cannot insert a value in foreign column. You cannot insert a CID value here or a department number here unless it exists in the parent, unless it exists in the parent CID column or a department number in the department number column in the department. That is what I am saying. Enforces referential integrity. Are you able to understand?
Yes.
Okay, so let's take up the diagram. Let's take up some characteristics. Characteristics of a foreign key. Okay, characteristics of a foreign key. What are the characteristics of foreign key? Let's take down. We can have multiple foreign key in a table. That's not a problem. Multiple foreign key in a table. That's okay. The next thing is that foreign key can accept a duplicate, and then repeated values also it can accept. Foreign key can accept null values also. And then foreign key is not a combination, is not a combination of, is not a combination of unique and not null constraint, not null constraint. The next important thing is that, for an attribute or a column to become a foreign key, it is mandatory that it must be a primary key in its own table. Okay, this is very important. For an attribute, attribute in other words is nothing but column. Okay, so for a column, I will write for a column to become a foreign key. For a column to become a foreign key, it is mandatory that it must be a primary key. It must be a primary key in its own table. Are you able to understand? Unless and until it is not primary key in its own table, it cannot be a foreign key in another table. Okay, understood?
Yes.
Foreign key are present in child table, are present in child table, but it actually belongs to parent table. Actually belongs to parent table. The next thing is that foreign key, also known as referential integrity constraint, is also known as referential integrity constraint. So this completes your constraints. And we have one last constraint, that is null constraints. We will be discussing that in the next class. So today we understood what are constraints, why do we need them. We understood not null constraint, unique constraint, check constraint, primary key constraint, characteristics of primary key and foreign key, characteristics of foreign key, and this diagram we have understood.